Today we're looking at differential equations, and these are just equations which contain derivatives. So for example, a simple differential equation could be dy by dx equals x cubed. Now if I want to solve this, what it means I'm trying to do is to work out the original equation before it was differentiated, and in order to do that I'm going to integrate. So the solution to dy by dx equals x cubed is the integral of x cubed with respect to x, which would be x to the 4 over 4 plus c. Now this solution that we have here is called a general solution, and it's called that because we haven't got all the information yet, because we've got this plus c. If we're given some additional information, we can work out what c is, and then we can go ahead and find the particular solution. For example, if we were told here that when x was 1, y was 2, I could use that information to work out c. I'm substituting the 2 and 1 into my general solution, and I'm going to solve it for c. So 2 is equal to 1/4 plus c, so c must be 2 minus 1/4, which is 7/4. Now that I've worked out c, I can put this back in to the general solution, and I'll have now a particular solution. And so here I have the particular solution. Let's go right ahead and look at some of the examples from our notes. Okay, the first example on page 6, we're given the equation dy by dx is equal to x squared minus 5. We're also given the additional information that when x is 3, y is negative 4. So I'm going to integrate this to get my general solution, and I'm going to be substituting in the 3 and the negative 4 to calculate c, so that I can then have a particular solution. So y is equal to the integral of x squared minus 5, which is x cubed over 3 minus 5x plus c. This here is the general solution. Now I know that when x is 3, y is negative 4, so I'm going to substitute those in to calculate c. So negative 4 equals 9 minus 15 plus c. So negative 4 equals negative 6 plus c, which means that c must be equal to 2. I can now go ahead and substitute that into my general solution. Y equals x cubed over 3 minus 5x plus 2. And that's the particular solution. Now the notation can come as function notation or Leibniz notation in the same way as it did when we were doing differentiation. Example number 2. So we're told that f dashed x is equal to x squared plus 1 over x squared plus 2/3. So the original function will be equal to the integral of this whole expression. I'm going to just do the preparation at this point. So x squared plus, that will be x to the negative 2 plus 2/3. Now I'm going to integrate all of these separately. I'm just not going to draw all the integral signs. So x squared integrates to x cubed over 3. X to the negative 2 is x to the negative 1 over negative 1. 2/3 is 2/3 of x and plus c. I'm going to tidy up at this point. So f of x is equal to x cubed over 3. This negative one on the bottom means the whole fraction is negative. I'm going to move the x down to get rid of the negative in this, plus 2/3 of x plus c. And this now is the general solution. Now I'm also given the information in this question that f of 1 is equal to 4. Now it's been written in a different way because we're using function notation, but it means the same as when y equals 4, x equals 1. So what I'm able to do now is substitute x with 1 and y with 4 and work out what c is. So 4 equals 1 cubed over 3 minus 1 over 1 plus 2/3 of 1 plus c. So 4 is 1/3 minus 1 plus 2/3 plus c. So 4 is the same as c. Now I'm going to use this to create the particular solution by substituting into the general solution. So f of x is equal to x cubed over 3 minus 1 over x plus 2/3 of x. Instead of plus c, I'm writing plus 4. And that is the particular solution. Okay, our understanding for today. What is a differential equation? What makes an equation differential? And what steps do you take to solve this type of equation? And what is the difference between a general and a particular solution? We calculated both a general and a particular solution in the two examples that we've just done. We're now ready for exercise 9Q. Questions 1 to 5 are level C and questions 6 are AB. None of these are unit level, they're all exam level.